Welcome, class. Today our session title is Week 9, Session 36, Percent Yield and Error Analysis. We will move slowly and make the chemistry understandable. Your goal is to calculate percent yield and interpret sources of experimental error. Listen for these key terms: actual yield, theoretical yield, percent yield, error, purity. First, keep the three chemistry levels together. Theoretical yield is the maximum product predicted by stoichiometry. Actual yield is what is collected in the lab. Percent yield compares the two. When you feel stuck, ask, what did I observe? What are the particles doing? And what symbol or calculation represents it? The core model is this: percent yield equals actual yield per theoretical yield times 100%. Units must match before dividing. Do not rush to an answer. Build the model first, then let the model guide the calculation or explanation. Now, let's work an example. Calculating percent yield. A reaction should produce 12.0 grams of product, but a student collects 9.60 grams. Percent yield equals 9.60 divided by 12.0 times 100%, which is 80.0%. The number says the student collected 80% of the predicted maximum. Notice how the answer comes from evidence and reasoning, not from guessing. Here is a second example. If a student reports 105% yield after filtering a precipitate, the product may not have been dry. Extra water adds mass, making the actual yield appear too high. Now answer this self-check. What is percent yield if actual yield is 8.0 gm and theoretical yield is 10.0 gm? A strong answer should include 80%. Hint: use actual divided by theoretical times 100. Before you leave, practice actively. Task 1. Calculate percent yield for 3.25 g actual and 4.10 g theoretical. Task 2. Explain one reason percent yield can be less than 100%. Task 3. Explain one reason percent yield can appear greater than 100%. At the end of your study, write one sentence beginning, "The chemistry idea I must remember is." For more practice and exam preparation, visit www.bridgetoexam.com.